Hello friends, welcome back to our channel. So today we'll see one more session in machine learning, that is feature engineering. So in our first stage of machine learning, so we are supposed to collect the data from different sources, and that data is not sufficient to train the machine learning model. So what we have to do is we need to do the feature engineering. That means we need to convert the raw data which has been collected into the meaningful inputs which we are giving as a training to the machine learning model. So today we'll discuss about how we are converting and what are the methods we are having to convert the raw data which we have collected into the meaningful inputs. So feature engineering. Feature engineering. So we'll see. First, let me write the definition. It's a process of converting raw data. Raw data means, so whatever the data we have collected from the different sources, converting raw data into meaningful inputs. Meaningful inputs to train the ML model. To train the ML model. So this is the main task. Okay, so how many ways we can convert these things means, first, handling the missing values. So our raw data can have a lot of missing values. So handling missing values. So we'll go one by one. So the first one is a handling of missing values. So definitely some kind of data will be having some missing values. Okay, and also the data which we have collected may have the duplicates also. So particularly if the data is having some missing values, how to handle this one? Okay, so automatically it will reduce the accuracy. If there are any missing values, it may reduce the accuracy, and also it may give a poor predictions. So final step is a predicting the result, right? So that predictions may also be poor. So we need to avoid that missing values. So for example, let us take some data. So employee data. So let it be age, name, sorry, let me write here, name, age, salary. So for example, if you consider this one, some name Ravi, let it be some 25, and let it be some 50,000 salary. Okay, Sundeep, let it be some 35, let it be some 70,000. Okay, and Saradhi, let it be some 40 and 75,000. Okay, so this is the data. For example, if the age is missing for this particular record and the salary is missing for this particular record, so how to handle these kind of things? So this automatically gives a reduce of accuracy, so we'll get definitely a poor predictions. So what are the methods we are having to avoid this, to handle these missing values? So one is, we can calculate the mean, median and mode, and we can replace the missing values with those things. So we can replace with mean, median, and I'm erasing this one, mode. So we can calculate these things, and simply we can replace the empty or missing values with these values. And another one, replace with a constant value. Replace with any constant. So here the constant can be any value. Okay, or you can simply use unavailable. unavailable, okay, or you can use unknown. So like that you can use any constant to fill the missing values. And forward fill and backward fill, forward fill and backward fill, this is a one more way to replace. See, for example, I'll write one more here, Saradhi, and 40 and 75,000, right? So let us assume this is not there. So you can use a forward fill. So whatever the data available in the next field, that you can replace here. Backward fill, previous data can be repeated here. So this is called as a forward fill and the backward fill. So this is a one more way and one more method to handle the missing values. And simply the last one is a prediction. So blindly you can predict some value to fill the missing data. Okay, so whatever it may be, this should not be there, the missing value should not be there. And also you can ignore or delete some rows or columns. So if this is also one option, you can simply delete the rows or columns which are incomplete. Okay, so here the data is incomplete, so we are handling this kind of data. So these are different methods we can handle the missing values. So automatically if you apply all these things, any one among these things, so automatically that will give the improving the accuracy, and also the predictions will be high. Okay, now this is the first method. Okay, this is the first one, handling the missing values. Next one, feature creation. See here the name itself indicates creating the features. Feature creation. So here the name itself indicates it creates new features from the existing one. So it will be creating new features from existing. So example, let us take some example. So we'll see a lot of methods. So how it will be done, right? The first one is a mathematical structures. Mathematical structures. So in this mathematical structures, for example, if you are having height and weight, height and weight. So for example, if there is any fitness data, right? So a person is having some height and weight, these two are the different features. So from this you can calculate BMI. BMI. Okay, so if you are having some longitude and latitude, from these two we can calculate the location, right? So like this we can calculate, we can use some mathematical formulas, and we can create a new features. So these are the new features. Okay, new features. Next, date and time. So this one also important, date and time. So if the date is in the form of some 21/05/26, so instead of giving this one, so you can identify the day. Okay, month, year, weekday, and you can also predict whether the day is weekend or weekday, right? So all these kind of new information can be created or from the existing data. Okay, this is the thing. Next, combining multiple features. combining multiple features. So combination of two features. Okay. So for this, you can see, if you are going with some sales records, so if you have collected some data regarding the transactions, so you can have a quantity and price. So from this you can calculate, you can combine these two and you can get the purchase bill. Okay, so combining these two and we can calculate the purchase bill. Even this latitude and longitude will also comes under this combining the multiple features. Okay, so from the existing we are creating a new one. Similarly, splitting splitting into multiple features. So we are having only one feature that will be splitted into multiple features. So for example, let us consider any email. Okay, any email. For example, abcd at some gmail.com. From this information you can get username as well as domain name. Username and domain name. So username is abcd and domain name is gmail.com. So from the one feature you are dividing, or you are getting the multiple features. Okay, splitting into multiple features. So this is the feature creation. So creating a new feature from existing one. So here all these are existing, and from this existing we are creating a one more feature. So this is a feature creation, second one. Coming to the third, encoding technique. Encoding technique. So here majority of the ML models will not be understanding the text related labels. So it will be understanding only the numerical values. So conversion of the text related labels into numerical form is a encoding technique. Okay, so converting text labels into numerical forms, right? So in the, what are the methods we can use to convert these things is, the first one, labeled method. Labeled method. So in this method, for example, if you consider any fruits like apple, orange, mango. So in order to recognize these things, we can simply replace them with 0, 1 and 2. So we are giving some numerical values for these particular names. That means these are the text labels. Okay, these are the numerical values. So here we are assigning 0 with the apple and 1 for an orange and 2 for a mango. So ML model will be recognizing these things rather than this one. So this is the labeled method. Another one is one hot labeled method. So here we'll be giving some binary values. Binary values. For example, let us take some red, green, blue. So the binary values will be given. For red it will be 1 and remaining will be 0. And for green remaining will be 0 and green 1. And for blue remaining will be 0 other than blue. So like this it will give some binary values. Binary values, that is a one hot labeled one, right? So we will be using a lot of text labels in our raw data, like these names, or you can use booleans, yes or no, okay, true or false. So like that we will be using many of the text labels. Instead of using this one, we can go with this labeled or one hot label, right? So like this, we need to encode the text labels into the numerical format. So all these cases, one common advantage is it will improve the accuracy and the predictions, right? So for the same reason, we are using these many things for in the feature engineering. Next, feature scaling. Feature scaling. So in this case, I'll give an example first. See, if you go with an employee record, two fields, let us take age and a salary. So obviously, the age will be of 2-digit number. It will be ranging between some 20, let it be 22 to some 60. Okay, 60 or 65. It will be 2-digit number. Salary, it will be some 50,000, and it may be about 6-digit number also. 6-digit number, right? So how can the system or machine able to work with these two different numerical data? So this is very small, but this is very big, right? So how the system can do? So this is called a scaling. Means collecting multiple features and making them in a single range. So we need to convert both the things. So both are numerical, right? Both are numerical. So here both the things will be settled down to a single range. Okay. So that is called a feature scaling. Making multiple features come under single range. Hope you understood. So age is only 2-digit, salary is around 6-digit. So both are different. Okay, so we need to bring both the features under the single range. So here the methods used for this one is min max normalization. Min max normalization. So what is this min max normalization? Let us take an example for this one so that you can understand. So let us take some 20, okay, and some 50,000, and here some 40, and here 60,000, and here 45, sorry, 50. Let us take a round of numbers. So it will be some 70,000. Okay, now minimax normalization means the formula x minus x min by x max minus x min. So you need to consider each and every value, and you have to apply this formula so that you will be getting a single range. For example, let us take a 20. So for 20, what happens? 20 minus x min. So minimum among these things. So 20 divided by x max, 50 minus 20. 50 minus 20. So which is nothing but 0. Okay. Next, second, x minus x min. So 40 minus 20 divided by, okay, 50 minus 20. How much is this one? 20 by 30. That is a 2 by 3. 2 by 3. It's around how much? 0.6. Let it be. Next, third one. 50 minus 20 divided by 50 minus 20. So which is nothing but 1. So you can get these values as, okay, 0, 0.6, 1. Apply the same to the salary also. Apply the same to the salary also. So let us consider the first one. So 5,000 sorry, 50,000 minus x min, among these one minimum value, 50,000 by 70 minus 60, 70,000 minus 60,000, how much value will be getting? 0. Second one, 60,000 minus 50,000 by 70,000 minus, here minus 5,000, right? Yeah, 50,000. 50,000, how much will be getting? So 60 minus 50, 10,000 by 70 minus 50, 2. That means 1 by 2. Okay, so the result is 1 by 2 here. Next, 70,000 minus 50,000 divided by 70,000 minus 50,000. How much you will be getting? So 1. So for this it is 0, for this it is 0.5, for this it is 1. So you can see the age range is from 0 to 1, salary again the range is from 0 to 1. So we are getting two different features into the same range. So for that we are using this method called min-max normalization. So similar to this min-max normalization, there is a one more method, that is standardization. Standardization, also called as zero normalization. Okay, so here the formula will be x minus nu by phi. So where x is a current value, nu is a mean, and phi is a standard deviation. So in this method, we need to find mean and standard deviation for all these things, and then we need to apply this formula, so that you will getting the, we are getting the same range for these two different features. Okay, so these two methods are used for feature scaling. Next one, binning. This is a one more feature engineering. Binning means converting or grouping, you can say it as a grouping, numerical values into categories. Simple grouping and numerical values. If you are having some numerical values, you can group them into some categories. For example, let us take some population. Okay, so you will be having some age, right? So some 5, 14, 27 and some 70. So these are the ages. So you can group these members as a child. So you can get the range, okay, a range of age who belongs to the child category, and this belongs to teenagers, and this belongs to adults, and this belongs to senior citizens. Okay, so what we are doing, so we are grouping all these numerical values into different categories. So this is called a binning, very simple process. Okay, then the last one, already we have discussed about this one, that is feature selection. So we'll be collecting a lot of data. Okay, we are collecting a lot of data. So among that data, we have to select only the essential information, that means important information, which makes our model to predict efficiently, right? So we can ignore the unwanted information. For example, let us take a student performance. First let me write the process, the functionality. So selecting important information and ignoring unwanted information. Okay, so example, let us take an example. Student performance. Student performance. So the data which we have collected is name of the student, roll number, uh, studied hours, attendance, hobbies, right? So this kind of data we have collected, right? So in order to predict the student performance, what are the important information? What are the important information? Simply you can go with studied hours as well as attendance. So these two are needed to predict the student performance. So unwanted information, see, unwanted information. So you need not bother about a name. So because the name of a student doesn't impact on the student performance. Similarly, roll number. So just to display the person who got a highest performance, I mean highest percentage or the performance result, you require the name and roll number. So this name and roll number doesn't show the impact on the student performance. And also hobbies. Also hobbies. So you can avoid these unwanted information. You can ignore those unwanted information. So you can select these two important information because the student performance directly depending upon how many hours the student have studied and what is the attendance, how many days the student have attended the school or college. Okay, so this is called as a feature selection. So selecting the only the important information and ignoring the unwanted information, right? So these are the different approaches to convert raw data into a meaningful inputs. So hope you understood. I'll write the complete methods and we'll close, right? So the first one, handle or handling missing values, feature creation, encoding technique, feature scaling, binning, finally feature selection. So these 6 methods are used to convert raw data into meaningful inputs. So what is the result? What is the result means improves accuracy, better decision makings, that means the predictions, training faster. So the training of machine learning model will be done very fast. So all these things are the result of converting the raw data into meaningful inputs, right? So I'll stop here and hope you enjoyed the session, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed the session, like my session, Share my session with your friends and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.